Hi mga numbers, how are you all? Hope everything is well. Welcome back to Wang RV channel. First of all, don't forget to like, comment, share, and subscribe to Wang RV channel. And if you'd like notifications and updates on all of my videos, please click the all notifications bell. Are you ready for another math lesson today? Let's go! At this time, let's focus on exponents. What is an exponent? How do we write it? And how do we read it? Second thing, when do we use exponents in real life? Is it really important? Third, how do we calculate exponents? And the last is the summary of what we'll be learning today. Let's go along. So what is an exponent? The exponent of a power is the number of times that the factor is repeatedly multiplied. Let's take a look at this. So this small number at the top right of the large number is called exponent. It is also called an index or a superscript. This is a little digit that is placed above and to the right of any number. It refers to the number of times a number is multiplied by itself. So remember that. On the other side, the base of a power is the repeated factor in a power. Let's take a look at this expression. So the base is 5 because this is the large number that is at the bottom left of an exponent. This is the factor that is being repeated or multiplied repeatedly. An expression that represents repeated multiplication of the same factor is called a power. In algebra, we call this as exponential expression. This consists of the base, exponent, or we call it index, and so if you put them together, we call it power or exponential expression. So remember that the parts of a power or exponential expression are base and exponent. And if we have this base and exponent together, we call it a power or exponential expression. In algebra, we can have a variable to represent the base and exponent. So remember that the exponent is the value that specifies how many times the base will be multiplied by itself. So it's like an indicator. And the base is the number or variable that is being multiplied repeatedly in the expanded form. So it is being written as b representing the base and n as the exponent. So b to the nth power. So how do we read and write power or exponential expression? Here's how it is. First, we can say 5 to the second power. And this expression can also be read as 5 raised to the power of 2. And we can say 5 squared. And when we are writing, we can write the base first as the large or the big number. And at the top right corner, we can write a small number, and that is your exponent. So here's another example. How about cubed? So we can say 8 to the third power, or we can read it as 8 raised to the power of 3. And last thing, we can say 8 cubed. And of course, your base is always a large number, and the small number at the top right is your exponent. And remember, 3 can be read as cubed. Exponents, index numbers, powers, and indices are used in lots of parts of our modern technological world. They are used in computer game physics, pH and Richter measuring scales, science, engineering, economics, accounting, finance, and many other disciplines. So let's take a look at the details on our next slides. Exponents are used in computer games. I know you will love this. Computer games use game physics engines, which are low-level programs inside the game to calculate the movement, interaction, and the geometry involved with the game. This involves multiplying powers containing exponents. If the mathematics isn't correct in the game engine, then the game is not going to play at all like we would expect it. So, no game, no fun, right? That is why exponents are very important. The use of exponents is very vital in monitoring the spread of viruses and disease. Viruses such as flu, COVID-19, and its variant can spread at exponential rates, causing epidemic affecting millions of people. We use exponents to trace and monitor its spread. We also use exponents in real life through monitoring bacteria exponential growth. Once bacteria and mold start growing in food that is not refrigerated, it reaches harmful levels very quickly. We can say exponential, so it's fast. So we use exponents on that. We use exponents to represent very large or very small numbers. Powers of 10 exponents called scientific notation. Remember, we had this on my previous video. This notation is used to specify very large amounts, such as the distance between stars and planets. And Earth to Moon distance is about 4 times 10 to the 5th kilometer. So we use exponents on these distances. Population is increasing at an extraordinary rate, especially in the developing regions of Africa, India, and China. So the world's population is growing. How is it being accounted? Well, through using exponents or exponential rate. Additionally, exponents are used to measure the strength of earthquakes. So level 1 earthquake is 1 times 10 to the first power, and the level 2 earthquake is 1 times 10 to the second power, and so on. Last thing, exponents are often used to describe a computer's memory. For example, 1 gig of RAM means that we have 1 times 10 to the 9 bytes. And most of us cannot work online without our computer or our phone or iPad. The same way that computers depend on its memory. Thanks to exponents, they make it all happen for us. There's a lot more ways where exponents can be used, but I will let you discover more of them. Okay? So there's a lot more. So let's go along with the main thing. How do we calculate exponents? Remember that the exponent or the index tells how many times to multiply the base by itself. On this expression, we have 2 to the 4th power. 2 is the base and 4 is the exponent. So this is not 2 times 4 equals 8. That is incorrect. So this is how it is. 2 to the 4th power is 2 times 2 times 2 times 2. So remember that 2 times 2 is 4, times 2 is 8, times 2 is 16. In algebra, we can present this as 2 to the 4th as 2. We use the dot instead of the x as a symbol for multiplication. So we can say 2 times 2 times 2 times 2. This is 4 times, and that is equal to 16. Here are some important notes that we need to remember in dealing with exponents. 5 times to the 3rd power is not equal to 15. So we are not multiplying the base and the exponent. We multiply the base by itself 3 times. So on this expression, we say 5 times 5 times 5. And that will be equal to 125. Next thing, if we have 0 to the 0th power, this is usually undefined. However, if we have 5 to the 0th power, that is equal to 1. And whatever is the base, if it is raised to 0th power, it will always be equal to 1. Example, we have 1 million raised to 0th power. That will always be equal to 1. And next thing, 5 to the 1st power is equal to 5. So whatever is the base, if you raise that to the 1st power, it will always be the base as the answer. So example, you have 1 million raised to the 1st power, that is equal to 1 million. I hope you get that. Here's another example, 2 to the 3rd power. So remember, the base is 2 and the exponent is 3. We can also say 2 raised to the third power or 2 cubed. We can present this as an exponential form, so that's how we have right now 2 to the third power, and also through expanded form, which is 2 times 2 times 2. And finally, our answer usually is in the standard form, which is 8. So if we multiply the base by itself 3 times, it will be 2 times 2 is 4 times 2 is 8. So we have the exponential form, expanded form, and the standard form usually is our answer. So here's an additional example. We have 4 to the 5th. This is in exponential form. So let's change that to expanded form as we calculated, and then our final answer will be in the standard notation. So 4 to the 5th power can be written as 4 to the 5th power, or 4 raised to the 5th power, or the other way around. And in expanded form, we can have it 4 times 4 times 4 times 4 times 4. And so if we multiply this 4 times 4 times 4 times 4 times 4, we can have 1024 as our final answer. So that's how we do it. I hope you get that. Here's how exponents work. Let's remember that whatever number is raised to the 0th power, it will always be equal to 1. So 3 to the 0th power is equal to 1, and 3 to the 1st power is always equal to the base, which is 3, and that is equal to 3. 3 to the 2nd power will be 3 times 3, which is equal to 9, and then 3 to the 3rd power means you are multiplying the base, which is 3, 3 times by itself. So 3 times 3 is 9 times 3 is 27. And 3 to the 4th power means 3 times 3 times 3 times 3 is equal to 81. Let's have this practice. I'm giving you 1 minute to do this. So I'm giving you 6 to the 5th, change that to expanded form, and present your answer in standard notation. Ready? Go! I bet you are done. So let's take a look at your answer. So if you've got 6 times 6 times 6 times 6 times 6, you're correct. And multiplying this, 6 times 6 times 6 times 6 times 6, you should be getting 7,776. If that is true, then you are correct. Let's have the second example. X to the 3rd. How about that? How will you present that in expanded form? And how will we get the standard notation or our final answer? So, here's how it is. Since the exponent is 3, we have to multiply the base 3 times by itself. So, since our base is x, so we just multiply x times x times x. So, for our standard notation, we can assign a value for x. So if x is equals to 2, we can say that 2 times 2 times 2 is equal to 8. So usually when we have a variable, we can just substitute the value there. So we can have an answer in standard notation. Let's go along with number 3. 4 to the 2nd power plus 3 to the 1st power. How about that? Can you do that? I'm giving you another 30 seconds to try. You can go along. So remember, the exponent indicates how many times you multiply the base by itself. And remember the important notes that I have given you. Those that are raised, 3rd power, and the 1st power, those are special cases. So remember those things. So let's check your answer. Expanded form, we can write it as 4 times 4, which is 4 to the 2nd power, plus 3. Why 3? Because 3 to the 1st power is equal to 3. This is the base itself. So multiplying and adding them would give us 4 times 4, 16, plus 3 will give us 19. Easy, right? Okay, let's go to the fourth example or practice. 7 to the fourth minus 8 to the 0th power. Can you try that again? Alright, for another maybe 20 minutes or 20 seconds instead. I'm sorry. Right? Ready? Let's take a look. So you should have 7 times 7 times 7 times 7 because the exponent is 4, so we are multiplying the base, which is 7, 4 times. Or 4 times itself. 7 times 7 times 7 times 7 minus 1. So you should have 2,401. The answer for 7 times 7 times 7 times 7 minus 1, which is the answer to 8 to the 0th power. Remember, whatever is being raised to the 0th power, it will always be equal to 1, except 0, which is undefined. When you raise 0 to the 0th power, that is undefined. But other than that, non-zero digits will always be equal to 1 when it is raised to 0th power. So we've got 2,401 minus 1, and that is equal to 2,400. I hope you get that. However, you can always go back to this video whenever you forget something. What if we will solve 7 to the 11th power? You might say, Miss Borromeo, that's too long. Oh yes, it is. So we have to write it down. 7 times 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 7. And that is equal to 1,977,326,743. So can we make it shorter, or is there a shortcut? Oh yes, there is. We can use our calculator, and to save some time, we can use these symbols on your calculator so that you can calculate exponents easily. So remember these symbols on your calculator. So here's one more example with your calculator. Solve 3 to the 15th power. If you have calculator, you can do it now. So remember the symbols that you have to use. We can do like this way. So 3, which is the base, and then the symbol, and then the exponent 15, and that you should be getting 14,348,907. Did you get it? Perfect. One more thing to remember. Exponents can express powers of 10. So the exponent will tell you how many zeros are in the number. And this is only applicable for exponents of 10 or powers of 10. So we can say 10 to the first power is equal to 10, which has only one zero. So the exponent will tell you or indicates how many zeros do you have in your answer. So 10 to the second power means 100. So it has 2 zeros. And 10 to the third is equal to 1000, which has 3 zeros. So remember, these are only applicable for powers of 10. To summarize what we have learned about exponents, let's remember these things. Remember that a power or exponential expression consists of the base and the exponent. If we have this expression 10 to the 9th power, we can present it as 10 times 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 10. So it is multiplied, or the base is multiplied 9 times by itself. So if we multiply that, we will be getting 1 billion. And remember, if it's powers of 10, we can just count the number of zeros indicated by the exponent. So since the exponent is 9, we have 9 zeros in it. So to easily remember, multiply the base by itself as indicated by the exponent. So that's it. In my next video, I will be discussing the laws of exponents. So please stay tuned and we'll see each other again. Thanks for watching. So please don't forget to like, comment, share, and subscribe to Weng RB channel. Thank you and God bless. Bye.